So hello everyone, I am Dr. Satish and in this video tutorial we'll talk about uh, types of analysis. We have been talking about variables and data measurement techniques in research through different lecture series. Now in this series, this is lecture number 4 by 8, fourth lecture of the 8 lectures, and today we'll talk about types of analysis. So before this we discuss about variables and types of variable also. So hello everyone. Now we'll talk about types of analysis and measures of central tendency. Now when we talk about types of analysis, or even we can call it as types of statistics also, or different applications. It may be descriptive analysis or descriptive statistics, and inferential analysis or inferential statistics. So descriptive and inferential. We'll talk about these two types of analysis. When we talk about descriptive analysis, generally uh, this is defined by measures of central tendency. Now, in measures of central tendency, will talk about mean, median, mode, geometric mean, harmonic mean. So these are the different types of mean, and we'll discuss about them. Now, on your screen, you can see there is a table on the left side, and you are supposed to calculate the mean. There are some roll numbers of 5 students, and some hypothetical names are also mentioned. So now question is that, is it possible to calculate the mean with the help of this data? Now we can see this is a categorical data. Now names are categorical in nature. Okay, so it is very difficult for anyone to calculate the mean with the help of these 5 names or the categorical data. Even if we refer to the roll number, then also it is very difficult to calculate the mean, because we are supposed to calculate the mean of the performance, or for any mean for any specific characteristics. And if we look at the table on the right side, we can see there are two sections, section A, section B, and these are the marks of some students of both the section. Now we are supposed to find out which class is more intelligent. Now how we will do this? So while finding out this, we'll calculate the mean. Now in this case, we'll calculate the mean by adding all the observations and by dividing by the number of observation. Now in this case, we can compare the mean score of section B is higher than the mean score of section A. So we can differentiate, we can find out, we can conclude that section B students are more intelligent than the students of section A. Now, so this is the application of mean, how we have used the mean as a measure of central tendency to find a solution to our problem. Now, if we compare mean with the median, let's consider one more example. Choice of formula, or which class is more intelligent. We need to find it out with the help of mean or median. Now again, in the example is related to similar previous example only. Here also we are having two sections, two classes, and the marks of students are given. Okay, now how will you find it out? Now we have calculated the mean as well as the median for both the section. Now in this case, we can see the mean of section B is higher in comparison to section A, whereas if we talk about the median score of class A is higher than the score of class B. Now mean and median both are used in different scenario. Mean is calculated to find out the actual value actual value or the actual result or the actual score while comparing two different groups. And median is the central value of the data set. When a data set is arranged in a ascending or descending order, so it is a positional median is a positional mean, whereas the mean that we calculated, that is arithmetical mean or mathematical mean. Okay, now let's move further in measures of central tendency. We have some observations, and these observations are hypothetical and represent income of five different people. Now, the average of these five observation or the income of these five different person is 33,000. Okay, and if we calculate the median, then median is calculated by arranging this data set in ascending or descending order. Now in this case, median is also 33,000 or mean is also 33. Both are same. Now in a scenario, how do we find out the actual solution to the problem? Now let us say we'll study the impact of a single variable, single value when we calculate mean. Even a single observation can change the entire uh, average or the mathematical mean. Okay, whereas in case of median is the value of median is calculated by arranging the data set in a ascending or a descending order. So we'll see how a single value of mean can, or a single observation can change the entire mean value. Now in this case, we can see a Bollywood star. It is again a hypothetical example. Let us say now 6% join, and 6% joins in with a income. So the income of the 6% is much higher. Now we can see 3 crore. So the income is 3 crore, let us say, and whereas the income of 5 other person is much less. Now if we calculate the mean in this case, the entire mean will be changed. Here we are talking about arithmetic mean. Okay, so arithmetic mean, the new value of the arithmetic mean would be 50 lakh 27,500. Okay, so we can see the mean value has drastically changed, and this has resulted because of the single observation. So when we are calculating mean, even a single observation or a single value can change the entire mean of the data set. So arithmetic mean or median or all these measures of central tendency, they are the characteristics of they represent the characteristics of a specific data set under consideration. Now in this case we can see the outlier was this Bollywood star or the sixth person. The sixth person has a different value, different income, which is very like there is a huge difference between the income of this sixth person and the income of other five people. So single value can change the entire mean. So in such scenario, the mean may not be much beneficial for us, for the researcher. Now we can see the sixth person who joined this group was an outlier in this distribution. So it makes more sense to compute a median than the mean to describe the center of the distribution. Center of the distribution. So center of the distribution is calculated in different format. Now center of the distribution may be termed as the average also, or it may be termed as the mean also. Now when we calculate the arithmetic mean or mathematical mean, the center value is calculated by adding all the observation dividing by the number of observation. But even a single observation can change the characteristics of this entire data set. So in such scenario, mean may not be useful. So we can consider median also. So median can be calculated by arranging the data set in ascending or descending order. Median is a positional mean. Okay. Now there is one more type of average. So that is known as mode. Now we talked about mean, median, now mode. Mode is a frequent occurring value in a data set. Let us say if a single or any specific value is repeating again and again or multiple times, then we can also utilize, or we can also consider that value as the main value or the average value, which is representing the entire data set. So mean, median and mode, all these three different concepts are the measure of central tendency. Then there are other measures also, like geometric mean and harmonic mean. Okay, so there are some advantages and disadvantages. When we talk about the mean, the advantage is like it uses all data value, even the value of the single observation matters a lot and algebraically defined. And distorted by outlier. We just discussed the example of outlier, and even skewness also. Okay, so it easily get distorted by the skewness. If we talk about median, so median is not distorted by the outlier, not distorted by the skewness. The disadvantage of the mean are the advantage for median. Now there are some disadvantage of median also. Median ignores the most of the information, and it is not algebraically defined, because median is a positional mean. It is not algebraically defined. If we talk about mode is easily determined for categorical data. So if we are having any categorical data, and if we see some data is repeating again and again, then in such scenario the mode would be very useful and effective. But there is a problem, there is a issue with the mode also. It is not algebraically defined. So mean is algebraically defined, but median and mode are not algebraically defined. Okay, if we talk about geometric mean, so it is appropriate for skewed data, but there are disadvantages also. Only appropriate if log transformation produces a symmetrical distribution. Now different level of measurement and objectives call for different statistical technique. In this lecture we are talking about different types of analysis: inferential analysis and descriptive analysis. So descriptive analysis or descriptive statistics, similarly inferential analysis or inferential statistics. Now we are talking about different levels of measurement and objective calls for different statistical techniques. For example, it makes no sense whatsoever to find the mean and median or mode of a list of class roll number. This we already discussed. If we are having a list of the roll number, then that the roll number is not the list is not useful for us. We can't make any conclusion out of the roll numbers or the name of the student. If we are having the score, then we can get some conclusion. Okay, now a complete wastage of time, since the roll numbers are at the nominal level of measurement. The roll number or even the name, they are the nominal level of measurement. So in such scenario, it is very difficult to calculate mean. Now on the screen you can see there is a table, comparative table, which is about descriptive statistics or descriptive analysis versus inferential statistics or inferential analysis. These terms are used interchangeably: analysis or statistics. So descriptive versus inferential. Now there are different aspects. If you talk about the purpose, descriptive is used to describe, summarize and organize data, whereas inferential is used to make inferences, prediction and conclusion about the population. Focus of the descriptive is to describe what the data shows, whereas in case of inferential statistics the focus is to explain what the data means beyond the sample. If we talk about the key components and methods used in descriptive statistics, for example, central tendency, we just discussed about the central tendency, even variability, relative standing and relationship, all these concepts are covered in descriptive statistics or descriptive analysis, which is basically used for describing or depicting the data. If we talk about inferential statistics, then parametric tests such as t-test, ANOVA, multiple regression are used. Even non-parametric tests such as chi-square are also used in inferential statistics or inferential analysis. And the nature of analysis in descriptive statistics very simple and factual, whereas in case of inferential, the nature of analysis analytical and decision oriented. If you want to make any decisions or if you want to make the prediction, then inferential analysis is used. It is very helpful in such scenarios. Whereas if we just want to have a overview of the data, what is happening, and just want to represent that past data, then descriptive statistics is very helpful. If we talk about the example, so we can consider an example of average marks of a class. We discussed about this example also earlier. So average marks of a class could be an example or the case of descriptive statistics. And if we talk about example of inferential statistics, then for example, testing whether teaching methods significantly affect the performance of the students or not. Now in the previous case, we were considering the performance of the student by just looking at the average mark of the class. So that is a descriptive statistics. But if we want to study, or let us say we are considering a variable like teaching method, impact of teaching method, we want to study the teaching method significantly affect the performance of student or not. So in this case, this is an example of inferential statistics. Now on the screen you can see a comparative chart. This will give you more clarity about descriptive statistics or inferential statistics, or descriptive methods versus inferential methods. In descriptive statistics or descriptive analysis, we use measures of central tendency, measure of variability, graphical representation. In measure of central tendency, we already talked about mean, median, mode, geometric mean, harmonic mean. These are the measures of central tendency. And measures of variability, where we see the variation in the data. That includes range, variance, standard deviation, and interquartile range, IQR. So these are the different measures of variability. And there is one more method which is known as graphical representation. Now, in graphical representation, histogram, box plot, pie chart, so frequency table, all these are used to represent the data graphically. So there are three different methods in descriptive analysis: measure of central tendency, measure of variability, and graphical representation. And if we talk about inferential statistics, then probability distribution. This includes probability distribution, hypothesis testing, regression analysis, and working with the confidence level interval, confidence interval. So inferential statistics addresses the problem of making broader generalization inferences from the sample data to the population. The basic aim of inferential statistics is to use the sample score for hypothesis testing. So we work on a sample. In research, generally we work on a sample because it's very difficult to get the data from the entire population. So we choose a sample on the basis of different sampling criteria. We apply statistical test, and whatever the result we get on the basis of different statistic any specific statistical test, and then we conclude about the that sample, and we generalize the result for the entire population from which the sample has been extracted. Okay, so in inferential statistics we generally use for hypothesis testing. The basic aim of inferential statistics is to use the sample score for hypothesis testing. Let's talk about some cases or some examples in inferential analysis or inferential statistics. Is the average age of a population significantly different from 35? So in this case, we want to compare, we want to see the average age of the population or the data set is different from a number 35 or not. Second example, do urban and rural households differ significantly in terms of average monthly expenditure on food? Third is, are consumption expenditure and disposable income of household significantly correlated? Fourth is, does the advertisement expenditure significantly influence sales? Now, after going through these examples, we can see here in inferential analysis we are comparing two different groups. So when we want to compare the group, or when we want to infer something, or when we want to hypothesize something, or we frame some hypothesis, or we want to go for hypothesis testing, then inferential analysis is very helpful. So I hope this lecture was also useful for you. In this lecture, we talked about different types of analysis, and we focused on inferential statistics, inferential analysis, and descriptive statistics or descriptive analysis. Thank you so much.